So, good morning to all the participants and a warm welcome to all of you to the fourth day of the AICTE sponsored short-term training program on IoT powered solutions for healthcare innovations. So, today I'm proud to invite the invited speaker for the first session, Mr. Kumar Sachidanandam, sir. Sir is the CEO at AIC and University Incubator. He is also a co-founder of Ideology Ventures and the co-creator of Gigogig.com. Gigogig was started during the lockdown period quite recently, around March 2020. Sir has completed his MS in Software Engineering from BITS Pilani, MBA from Annamalai University, and BE in Electronics and Instrumentation Engineering from MBA from University of Madras and BE in Electronics and Instrumentation from Annamalai University. Sir has also completed PG in Intellectual Property Law from National Academy of Legal Studies and Research University. Previously, he was working as a senior director with Cognizant for more than 10 years and with Microsoft Corporation as an architect advisor for more than 6 years. Sir, we are privileged to welcome you to the session, and I would like to express my thanks on behalf of the management as well as thanks on behalf of the event coordinators for immediately accepting our invite to attend and be a speaker for this session. And also you were patiently responding to all our queries in spite of your busy schedule. We welcome you once again, sir, and thank you. Over to you, sir.
Thank you, Deepa, and thank you to the institution for organizing this event, especially during these difficult times. You know, getting everyone on board is very, very difficult, and you know, congratulations to the department head and various people, including your management, for organizing this. And most of all, right, all the participants, I see about 29, 30 people on this call. So it's very special. It's raining in many part of Tamil Nadu here. I don't know where you are all from. This is also morning on a working day. Thank you so much for taking this call.
So there are 49 participants as of now, sir, to hear your session.
49, okay. I see only 29. Okay.
Now it is 50. It will come up, sir.
Okay, all right. Thank you. So what we'll do is I'll try to make this a little more light and interesting for you. So you please feel free to stop me, ask any questions that you have. Let's keep this as a dialogue. If you want, you can as well type. So I'm able to see your messages here. So if you can type your questions, I'll probably try to embed your questions and answers on this meeting itself. So let me pull up here. I got a very visual based presentation. I do a lot of images, visual images. So my presentation is full of images. So that way we'll make it a little more interesting as well for all of you. Let's see. All right. Oh, so 1 second. Is just trying to set up technology always, you know. Yes. All right. Can you see my presentation? Are you able to see my presentation? Can you confirm?
Yes, sir, it's visible. AI and IoT.
The audio as well as the PPT is very clear, sir.
Okay, great. So let me also see if I can make a little more change to this. Just give me a second. All right, how is this now?
So visible, clear, sir. Full screen it has come.
Fantastic. All right, great. That's what I was trying to make. So this is about artificial intelligence and IoT and their application in the healthcare industry, right? So I wanted to talk a little bit about IoT and AI before I get into the healthcare. That's how I structured my presentation. Do you want me to cover these two elements in a high level before we go into healthcare, or you want me straight jump into the healthcare part and just be done with that?
So as per your how you
Okay.
suggest, yes, sir.
Okay. Thank you. So look at this, right? There are few things. Why are we talking IoT, AI, healthcare? Just not healthcare. AI and IoT is changing, the scenario, the landscape in every industry, and healthcare is not an exception. But before that, we have to understand why. Why AI and IoT now, right? Why not all these years? It's not that artificial intelligence and algorithm was not there before, but what is changing and what is changed now? Why should we be caring about it? Why should we be interested in the research as academicians? Why should we be thinking about startups and ideas in this field? And sometimes why should we also be a little worried about the rise of this? So the first one, right? There is a topic all the time when I go and do a session. People ask me, "Will computers take over us? Will computers kill us?" Right? I think the answer lies in this slide, right? Today, if you look at this, right, the rat brain. Today, our computing power is good enough to mimic a rat brain. We haven't come to a level of mimicking the entire human brain. Probably we need about 100,000 times of today's computing power is required to really mimic a human brain. So if anybody is asking, will computers take over? Not yet. We don't have technology to get to 100,000 times of computing power. Even the most supercomputers cannot do that. We are talking about the quantum computing per se. When that becomes a reality, there is a possibility, but it is a long way to go. So we are all safe. So the other thing, right? I'm sure many of you as professors have seen this. Some of you work with terminals, mainframe computers, punch cards. Then we have desktop computers. Then we had something called as client server. Then we had the browser-based application. Then we had everything on cloud now, right? So if you look at it, right, from a small tiny terminal to desktop to large computers to mainframe to cloud, this evolution is going on and on and on and on, right? Probably those who are familiar with the 1960s when we were studying in computers in colleges, right? Computers are very scarce. We used to go to labs and stand in the queue or book an appointment to access computers, right? Those were centralized mainframe computer. There used to be a computer room in server room in every college, in every department, in companies as well, right? Then we had the PC. Every desktop had one computer, not a blind terminal, but we had desktop computers on every desk. Then what happened is mobile, right? So we have mobile, so everything, our mail is on our mobile. Your on your desktop also you don't host anything right now. The Microsoft Teams that we are all using, it's hosted somewhere in the cloud. We run a small piece of software on our machine that takes this video and then streams it to the main server, and then it does all the processing, right? So from a centralized, we became distributed. From distributed computing, we have become centralized. Now, the next phase is, right, devices. It's called as the edge computing. The computational power is just not centralized, but it is also distributed. So we see this, seesaw, I call this as a swing, up and down, it goes and up and down and it changes. We don't know, maybe when the quantum computers comes, we'll probably become again centralized because the computing power is so huge there. We don't know where we are going, but this is the cyclical shift that we see. So we talked about Why is this happening? It's because of the central processing unit, the computing power that is there, the so-called Moore's law. And the second thing, right, 2015 was a milestone year in computational, especially the artificial intelligence community, because until 2015, the computer vision code that we all write as researchers used to recognize images with an accuracy about 70–75% only. But then in 2015, we had a computer algorithm recognizing an image 100% accurate. That's the breakthrough year for artificial intelligence, and that is the year we started seeing the shift from we call this as artificial intelligence winter. During a winter everybody goes into hibernation, right? Because there is nothing happening. So 2015 was a year we came out of the AI winter and we started doing a lot of work. But what enabled that is something called as the GPU. NVIDIA and a bunch of others have been doing research on this, and they kind of pushed this envelope. And if you look at this, if you're working in AI, it's all matrix manipulation, right? So you have converted everything into a bits. It's a matrix manipulation, and it's bits and pieces. You just manipulate it, do calculations and computation, and GPU enabled exactly that kind of calculations, and that is the one that led to this accuracy. So we talked about CPU, we are talking about the graphical GPU power, and the next one, right? This is something we have seen in our life, right? From a bulky phone to a bulky handset to low bandwidth GPRS enabled devices. So now we are able to do video calls. That's in our lifetime. We have seen this change, all of us, right? Some of our kids have grown with this, probably from 3G to 4G. They are starting with 3G, but in fact, some of us have started with 0G, I would call. But there was nothing G in it. So what happened is, right, from the 1G to 5G, right, each generation of the communication technologies have enabled the bandwidth, the communication bandwidth to go, and therefore the amount of data we are able to transfer from our devices to a central or another device has tremendously increased, and that's what changing the landscape now, and that's putting the hotbed for innovation in healthcare and other industries. So we talked about CPU, we talked about GPU, we talked about communication bandwidth because of the telecommunication innovations. The next one is about sensors. You know this, right? Have you seen these sensors in your labs? If you're an electronics or a computer or a microprocessor professor or a teacher, you will know these sensors. Our students use this all the time in their projects. And what is special about this sensor is that the price. How much is the price of this sensor, do you think? ₹200, 150 rupees, 300 rupees, 500 rupees. That's what is the price of these sensors. Not only that, for everything, starting from sound to photo to capacitive to flame to vibration to alcohol sensor to gas sensors, tilt sensors. So we have, just name it, for everything we have created sensors, and the sensors are also affordable. That's the point, right? So in fact, India has our tariff rates, custom duties are little expensive, and therefore the sensor cost in India is little higher. Even then, it is about 250 rupees. You skip a meal in a hotel, you can buy a sensor, right? So So the cost of sensors is coming down. This is another impetus for the change or the wave of change that we are looking at. So when the cost of these sensors, cost of computational power, cost of graphic processing, everything comes down, what happens is there are many devices getting connected to the internet, right? So if you look at it, about 50 billion devices, okay, starting from your mobile phone to CCTV camera. Almost every country in the world has installed smart CCTV cameras. Every city has, every street and nook and corner. Today the police is advising us to install cameras in our own house. So these devices are all getting connected to the internet. Think about the amount of data, the amount of information that we are generating and putting it up on the cloud server. That's mind-boggling, and it is not stopping now. Every device. I don't know whether you know. 2 days back, the truck drivers were striking against the government. Why? The government said every truck will have the GPS devices installed and the truck movement will be monitored. As simple as that. Suddenly, the truck drivers are shouting and saying, no, we will not agree to this. Now think about it. Every truck that is there on the road, if it is connected, the amount of data they will generate, the traction, the traffic. Now we can figure out what is happening, right? Now think about when such a mandate comes to all our cars. The government can track wherever you are going. Not only that, just think about where the traffic is there, where number of cars are there, right? So all this can be detected, and of course, one company that knows where the cars are on the road today is Google, because many of us, almost every cab driver uses Google Maps, and continuously the Google Maps is transmitting our physical location to Google, and that one company knows how many vehicles are on the road and where they are in traffic. They can actually build a traffic control system, right? Now that's the power of connected devices and the kind of things that we can do, right? Now I'm sure all of you are taking pictures. The number of selfies that we take, the number of images that we put on our WhatsApp and Instagram accounts is crazy, right? In fact, the number of photos have gone multifold than the number of emails. Earlier, it used to be the number of emails that we generate, but the number of images are now going phenomenally heavy, right? So we are generating just not structured data. Right? Earlier, the transactional system, the SQL server, the database systems, that all we do, they created what we call as a structured data. But now we are creating some crazy amount of unstructured data, right? So look at the volume. It's not in kilobytes and megabytes and gigabytes. We are creating zettabytes of unstructured data. Now, what is more interesting, right? The left-hand side bottom, look at this. The gray or the black chart is the business data. Now, think about it. The businesses do volumes of crores and crores or billions worth of transactions, right? Everything that we buy, sell, our salary, the transaction, credit card, everything is captured somewhere in a database, right? We would normally think that that is the data which is the largest. But if you look at it, the business data, think about all the stock market data, bank data, our enterprise data, even your college data, everything put together is the small black line at the bottom. The dark green is the sensor data. The sensor data means, the temperature, pressure, all the CCTV camera footages that we collect, all this put together is a sensor data. That the data that's coming out of sensors across the world is a dark green. The light green is the human data. What is it? Things that we store in our mobile phones, things that we take and share with others, the videos, the memes, everything, every data that we generate is humongous. It's humongous. So much so, many times we clean, sometimes it automatically gets a backup in the cloud, but it's all getting stored somewhere, and we are creating what you call digital junk. Somebody has to make sense out of it. So the just give me a second. There is an interesting slide that is missing out of this. Sorry. All right. Right. There we go. So if you look at it, right? So we talked about the rise of central processing unit. We talked about the rise of the graphical processing unit. We talked about the bandwidth that is getting created because of the telecommunication technologies like 1G to 2G to 5G. We talked about the sensors, the plethora of sensors, not only the sensors, but the cost of the sensors. Then we talked about the data, right? The data that is getting generated due to all the sensors and devices and so on and so forth. Now we'll talk a little bit about the algorithms. So algorithms are put together is what we call AI. I'll just run it through quickly. So what is AI? A machine or a code that has the ability to think, learn and reason like us. That is as simple as that, but it is also very aspirational. I don't think we have a perfect artificial intelligence system yet. But there are two other two other fields that are evolving within the artificial intelligence at a breakneck speed. One is called as machine learning, other one is called as a deep learning. Machine learning is an algorithm that has the ability for the machines to learn without we telling anything. That's as simple as that. Deep learning is one level below, which uses a different technique, which essentially mimics a human neurons, as simple as that. Let's look at this. The difference between machine learning and deep learning. So in a machine learning, for example, if I want to do my facial recognition, what you do is I take a picture of myself and I tell the computer in the picture of myself where my face is. So I actually have to mark my face and feed so many images of myself with the marked face saying that this is Kumar, this is where Kumar face is there, and if the face looks something like this is Kumar. Or you can take anything. It can be a car, it can be any image or an object that you can say, this is an object, this is what I am looking at, this is how the object looks like, and you have to actually mark or block, or specifically we call them as feature. So you have to define the feature of an object and then give it to the machine learning algorithm, and the machine algorithm does something called as classification, and it knows, okay, now when I get an image like this, when something exactly matches like this, that is a car, that is Kumar. That's how the machine learning algorithms work. So the key here is there is a human intervention which says this is Kumar. The future extraction or giving those data to the classification algorithm is what is the key. The difference in deep learning is that you don't say what it is. You can take picture of Kumar individually. You can take picture of Kumar multiple times. You can also take a picture of Kumar in a group and say, here is a set of pictures. In all these pictures, there is one person which is common, which is Kumar. Now the algorithm is going to do the job of feature extraction by itself and also the classification by itself. And then finally tell us whether Kumar is in a given picture or not. That's called as the deep learning. How are we doing so far? Interesting?
Yes, sir.
Anybody can type on the chat box. or anybody has?
Participants, please respond in the chat box.
Oh, they're all muted, is it? How's it going? The speed is good? Can we proceed? Okay, thank you, Jayanti. Thank you, Lavanya. So we were talking about the differences between machine learning and the deep learning. The key being the feature that we provide to these algorithms. Now, if you dig a little deeper, right, we'll take the right extreme corner, machine learning. Because you are marking the pictures, marking the data, saying that this is what is the data, please learn from this data. Since you are giving very pointed data for the machines to learn, the data requirement can be a little lesser if you use machine learning algorithms. Since you are actually marking all the data yourself, humanly possible, and giving the machine the data, what happens is if you give something beyond what is marked, the machine gets confused. It cannot deduce. So sometimes machine learning algorithms are less accurate. The training time, because it is very pointed data, since it can train with a lesser number of data, it takes less time to train. And many times machine learning algorithms can work on CPU because it is less CPU intensive. It doesn't do anything. It just takes your data, it trains on it. And therefore, it's very easy to do machine learning. Many times if you want to start your career on artificial intelligence, all of you have to start with machine learning. Bit of machine learning will help you understand what the concepts, and then when you go to deep learning, you'll be able to appreciate how much power that is in your hands. On the other hand, if you take a look at the deep learning, because you weren't giving anything, you were just saying, throwing a bunch of data and saying that go figure it out. Now that's where the problem starts. If you say, let us say this, right? If you give some 10 pictures of Kumar, all group photos, 10 images of Kumar, all group photos, and only one image of Kumar only with the face or like a passport size photo, what happens to the computing algorithm? It will find it very difficult to find where is Kumar. On the other hand, if we give 10 images of Kumar passport size photograph, different passport size photographs, and then one image of Kumar in a group photo, the chances of the deep learning figuring out who is Kumar, because there are 9 pictures of Kumar with passport size, because it knows very clearly how Kumar will look like. And then in one group photo, probably it knows how much 90% of the data is with it, and then 1% or 10% it picks up from the large photo. So therefore, when you look at deep learning, you have to have a large data set. If you don't have a large data set, there's no point in deploying deep learning. So if you are doing any project, or if any of your students are doing projects, and they're coming up with deep learning as one of the mechanisms to do artificial intelligence, the first thing that you have to ask them is, can you talk about the data set? How big or how large the data set is, because that will define the project outcomes or the accuracy of your prediction. So therefore, you need a large data set for deep learning, and accuracy depends on the large data set. The larger you have, the higher the accuracy. The smaller the data set you have, the lower the accuracy. And now that it has to deduce the knowledge from the data you are giving. So therefore, it takes a lot of time, and it has to go through multiple iterations, what we call them as multiple layers in deep learning. We'll talk about a little more. So therefore, it takes time to train, it has to go through all the permutation combination. Every layer has its connections like neurons, so it has to go through this. And many times, or 100%, you can still do it, but 80–90% of the time, deep learning needs a GPU to train properly or faster. And deep learning has a bunch of tuning parameters. We call them as hyper tuning. So we can change certain parameters and increase or decrease or fine tune the accuracy levels. So when people tell me they are using artificial algorithms or AI in their product or in their project, I start to internally laugh, because what is AI to one person is not AI to other person. AI per se is a very vast field. AI has machine learning, we talked about it. Within machine learning, we have deep learning, we just talked a little bit about it. What we haven't talked about is speech, right? So text to speech or speech to text, my bachelor's project was a speech project. I was doing text to speech. Then vision, image recognition, right? Today we have an algorithm that can do face recognition. I don't know if you can see the image, the one right behind me. If I turn my device a little bit, if you can see that there is this little TV on the wall at the right side corner, that's actually a custom designed face recognition device that I have built for our own use. So we have these vision. So machine vision and facial or image recognition is another area. And the next one is NLP. All of us have used Google Homes, Hello Google, and I have Alexa here. Hi Alexa, hello Alexa. In this room, actually, this is my home office. In this room, the lights are controlled by Alexa. I can say, Alexa, play a song. Alexa, switch off the lights, switch on the lights. Alexa can change the color of this light. These are multicolor LED lamps. So I can ask the Alexa to change the color of the lamps. This is enabled by something called as Philips Hue. Philips Hue is a brilliant product. So the Alexa is connected to the Philips Hue. So what happens in NLP is that it takes your speech, convert this into text, convert the text into the language to intent, and then takes the intent and figure out that you are trying to ask the Alexa to switch on the lamp or switch off the lamp, and then eventually activate it. That's what happens. A combination of speech, combination of NLP is the culmination of devices like Alexa or a Google Home. We have expert systems. We've been talking about expert systems. I'm not going to talk about that now, but the other one is robotics. Robotics is another field that uses artificial intelligence. So if somebody says I'm going to use AI, I'm using AI in our product, or we are doing a project in AI, it could be any one of this or a combination thereof. So therefore, when somebody says AI, please don't just take it at the face value. As professors and teachers, as experts, ask them, oh, you are using artificial intelligence. That's interesting. Tell me a little more about it. Just stop it at that. A complete open-ended question, and let your students tell a little more about it. He's going to fumble. He's going to, if he doesn't have a depth, he's going to fumble. Some might say, sir, we are using machine learning. Or some may say we are using OpenCV. OpenCV is an open source computer vision library. Some may say we are using NLP. That means the students are one level, you are peeling the onion of artificial intelligence, right? So the one layer of the peeling of onion will come to either machine learning or speech or vision or robotics. Then you can say, wow, great, you are using computer vision, OpenCV. Tell me a little more about it. Again, an open-ended question. Or you can say, oh, okay, machine learning. Okay, tell me a little more about machine learning. How do you do that? then he or she has to say, sir, we are using simple machine learning algorithms to do clustering. Sir, we are using deep learning to do image recognition. Sir, we are actually using NLP to build a bot. Now you peel the onion one level below, and now the student is starting to go to the next level and say, okay, great, you're using NLP. I see. How do you understand the intent of the speaker? Huh? So that's how, as teachers and faculty, you have to ask questions when somebody is saying artificial intelligence. At our startup incubator, when when a startup comes and a product team comes and says, we will be using artificial intelligence to transform this whole world, I internally laugh and ask them exactly the same question. Whoa, wow, fantastic, that's great. Tell me a little more about it. Tell me a little more about it. Okay, that's great. So the more you ask, tell me more about it, you can understand the depth to which the students or the startup founders are implementing the AI, and you can evaluate the depth of the knowledge, and you can decide how much to score or whether to incubate or not. So I'm going to focus a little bit on ML just to highlight how it works. In a traditional programming, all of us do this, right? If, else, elif, endif, all kinds of if statements. That's one thing that we teach all the computer programming classes. The first one, right? After variables, right? After addition, subtraction, multiplication, the next one is conditional statements. So in a conditional statement, many of our early expert systems also use these conditional statements. The workflow softwares use the same conditional statements. What we say is, if, that's a rule. If A equal to greater than B, that's a rule. The input is A and B. So you have to provide input A and B. You have to say if A is greater than B or A is lesser than B, you say what needs to be done. That's an action, right? That's the traditional programming. What changes in a machine learning approach is that you don't tell how it should be done. You all have to say, hey, here is my input. It is like, you go to home, you buy all the ingredients, right? So you buy vegetables, you buy pizza base, you buy the pizza sauce, and you buy capsicum, you buy onion, and you buy olive, and then go home and tell your mom, here are the things, all I want is a pizza. You can buy chicken, you can buy chicken masala, you can buy all the things that goes to making a chicken 65 or a nice chicken biryani, and go to your mom and say, here are the ingredients I bought from the shop and I want a biryani. How the biryani is made, how she is going to make, whether it is going to be a Hyderabadi biryani or it is a Chettinad biryani or a South Indian, North Indian or a Royal Bengalian, whatever it is, right? That rules are made by the mom. Now think about it. That's the machine learning. In machine learning, you say, hey, here are the pictures of Kumar. These are the pictures of Kumar. Whenever I give you a picture like this, all I want you to say, this is Kumar. That's all. So you say the inputs, you give the inputs, you say what is expected out of it, and you let the computer algorithms to define their own rules. And based on the rules, they predict. Sometimes it can be the right answer, sometimes it can be the wrong answer. Now that's called as accuracy. So you give the data, you train using the computer algorithms. What you have is something called as a model, and then you use the model to predict whether the future inputs are right or wrong. And if it is right, it's great. If it is wrong, it's not right, which means you have to fine tune your algorithms, and it's called as tuning. Right? That's how the machine learning approach works. So in machine learning, remember I talked about, are you using artificial intelligence? Great, tell me more about it. Sir, we are using machine learning. Wow, nice. Tell me more about it. So when you say machine learning, right, the student or your project or your startup has to say what they are doing. So there are three types of machine learning algorithms we talk about. One is called as a supervised learning. In a supervised learning, You tell what it is. I am giving you data on a flower. I am giving you a data on Kumar. So you have to say very clearly what you are giving and what you expect. When that happens, it's called the supervised learning, because you are very clearly saying what is expected and you are giving the input as well what is the expected output, and the machine learning algorithm does it. In unsupervised, you don't say anything. You just give inputs and say, hey, you know what, go figure. So in unsupervised algorithm, the machine learning algorithm, the algorithm figures out what could be possible outcomes and it tells you automatically. This is called as unsupervised learning. The reinforcement learning is about, so you give certain inputs, it assumes certain things and gives you an output. Then you say, you know what, if this is right, you give a reward. If this is wrong, you give a punishment, right? So it works on the reward recognition approach, which is the human tendency, right? How do we train our kids? Hi baby, how are you? Tell my name. Nama mama. You say very good. Next time you say tell my name, it's going to say mama mama, and then you're going to give a chocolate. Think about training pets. We train all the dogs and the pets training, right? So what happens in each of these times, when you ask them to do something and the outcome is rewarded, that becomes a positive reinforcement, right? So the cycle goes on and on and on. The more the positive reinforcement comes, the more the behavior will change. This is exactly is called as reinforcement learning. Now the reinforcement learning, right, is phenomenal. It is used in right now every computer game that you use pretty much uses some amount of reinforcement learning, because it understands from the player's behavior and changes the games automatically. Now think about, you are building a autonomous vehicle, autonomous navigator, autonomous car, or a surveillance vehicle. It is going into enemy territory and going to figure out things, or you're sending a rover, Mars rover kind of things. What happens when there is no human, or there is no way we can teach them how to behave in unexpected situations, right? So this is where the reinforcement learning as a concept is phenomenal use. And if anybody wants to do advanced research or a topic on artificial intelligence, please take up reinforcement learning. That topic per se has amazing potential. Within the space of AI/ML, this is an emerging field. So from AI, we said, okay, sir, we are using machine learning algorithms. Okay, you are using machine learning algorithms. Let's talk a little bit more about it. These are three, I call them as RCC. If anybody from civil engineering, this is easy to remember. RCC is called as a reinforced cement concrete. Every time you look up your ceiling, it is RCC roof. So it's very easy to remember: regression, classification, and clustering. RCC, right? So what happens in regression? You give a set of data, and it draws a connecting line across the data, a possible connecting line, and based on the line, it says whether the answer can be yes or no. For example, based on the historical data of rain pattern in Tamil Nadu, you can say whether it will rain in the first week of December, yes or no. Or you can say, based on the data that I have, what are the chances of raining today?
Sir,
Do you know this difference?
Sir, one interruption. Sorry to disturb.
Yes.
Sir, is a PPT shared, or you are not sharing the PPT? One of the participants have asked in the chat box.
Is the PPT not shared?
It is not visible, sir.
It's not visible, is it?
It's not visible, sir.
Oh, I'm sorry. So where did I mess up? Where did I miss?
So from that, this supervised and unsupervised.
This is the one?
Sir, the screen is not coming. The PPT is not shared.
Sorry, hold on a second.
Yeah.
I'm sharing, but it's not.
Your video is clear, sir, but the PPT is not shared.
Not sure. Let's check. Give me a second. Thank you so much for pointing this out. Okay, share content.
So generally you know that correctly diagram. So we are having component diagram. So component diagram we have to discuss this forward engineering and reverse engineering. So forward engineering so how we are going to converting to design to code. So in most of the companies they are using most of the software companies they are using different tools for converting this design to code.
Request the participant to mute. Someone has unmuted their. Sir, now your desktop is clear, sir.
Desktop is there, but you are not seeing the presentation, right?
I think you have not. Yes, sir, it is visible now.
Hold on a second. Let me change. Is this visible?
Yes, sir.
Okay, all right. So there's a problem with the screens. So if you look at this, right? Is this a screen we lost?
Also, the previous. Yes, sir. Yes,
Let's
this
see.
one. This
Okay,
one.
great.
Yes.
So let's go one level deep, right? The algorithms, right? So we are talking about range. Think about it, right? There are two questions we were about to ask. Based on the historical data, what is the percentage of rain today? Is one question. Based on the historical data, will it rain or not? The second question. Based on the historical data, where it will rain is the third question, right? Now, if you look at regression, classification, clustering, all of them have a play in these three questions. For example, will it rain, yes or no? That's called as classification. Is it a male or female? Based on the historical data, will it rain, yes or no today? That's called as classification. Based on the historical data, what is the percentage of possibility or probability of rain today is a probability curve. So that's regression. Based on the historical data, where it will rain, it's like a cluster. It will rain in Adayar, it will rain in OMR, it will rain in Avdi, it will rain in Tambaram, it will rain probably in outskirts of Chennai. So if you say that, that's called as grouping of the data into multiple clusters and saying where and all the impact can happen. Now that's called as clustering. So now think about it. When you have a student coming and saying that I'm doing a project on artificial intelligence, and you ask them, okay, what it is, then he says machine learning, then he says what it is, we are using clustering, you know that he is going to give you yes or no output. For example, if you have a set of students' data, based on the historical data, what is the chance of the student passing the exam or failing the exam? The minute if you are doing this kind of a transaction, you will be using the classification algorithm. Based on the historical data, for example, all the class attendance, all the assignment marks, all the internal marks, all of them you put together, right? Whether the student has studied in an urban area, whether the student has studied in a rural area, the attendance data, the past data, what is the CGPA the student will get? Whether he will get 7.5, 8.5 or 9.5, So if you are going to put this, that's a linear number, right? So if you are predicting a student the CGPA, it's not pass or fail, yes or no. It's more of a linear number. Then the student may be using a regression algorithm to do this. Now, based on the data that I have, the class of 30 or 70, how many of them will have first class? How many of them will have second class? How many of them will have a third class? And how many of them will fail? Now, this is neither regression nor classification, but it is clustering. So, given the data pattern, you are clustering them into groups, class 1, class 2, class 3 and fail. Now, that's clustering, right? So when we say artificial intelligence, I want you to know the difference. This concept you have to put in your mind, and that's the most important thing. So these machine learning algorithms, right, can be used for many areas, starting from image to fraud detection to feature extraction to recommendation system to segmenting your customers or segmenting your students to robotic navigation. Look at this, right? The basic one, forecasting, prediction, diagnosis, retention, all are typically classification and regression algorithms can be used. And unsupervised, grouping them automatically will be a classification algorithm. Reinforcement algorithm is real-time decision, right? The games, real-time, robotic navigation we talked about. So these are the application area of these algorithms. We'll switch gears and talk a little bit about neural networks. I'm not going to, we still have another. We have time till 12, right?
Yes, sir, we have till 12. 1 more hour is there, sir.
Great, thank you.
Yes.
So, do you think we should give a break 5 minutes, or we do a continuous session?
Sir, if you wish to take a break, we can. Participants, I think, will be able to listen continuously.
Okay, great. So neural network. The neural network is a little different. That it mimics the neurons of the human in a mathematical way at the highest level. But you have to remember, though we call this as neural network, they are not the replica of our human neurons. So if somebody says, it's exactly like neurons and it works exactly like this, that's wrong. It is a mathematical representation. It is an abstract representation. It is not exactly like a human neuron. But the point here is, there are a few things we have to remember. It has got input layer, output layer, and hidden layer. Let's make this very simple. Let's say you are giving a set of X-ray images. The X-ray images you are giving to the neural network, and you are expecting the neural network to train themselves and let you know whether the X-ray is a normal X-ray, or it is a pneumonia, or a COVID. That's all you need. So how many outputs you need? We want the neural network to tell you only 3 things. Whether it is normal X-ray, or a pneumonia, or COVID. That's all you need. So that means the output layer, right, will be 3. If you look at the output layer, you have the 4 bullets or 4 dots, right? So you will have 4 nodes. Here in this case, we'll have 3 nodes. And then to deduce your data into a multiple permutation and combination, what you do is you add additional hidden layers. The more the hidden layers, the more computational complexity, and sometimes the higher the hidden layers will give you a better input, better accuracy. Sometimes too much also spoils the accuracy. So therefore, in fine tuning, one of the fine tuning parameters is the number of layers, and we decide this. So that completes my quick overview of what is IoT, what has triggered the IoT in specific algorithms, the rise of the algorithms, what kind of computational algorithms are called as artificial intelligence, and types of AI algorithms, particularly machine learning, a little bit about deep learning. I think with that background, it's time to switch over to opportunities in healthcare, especially with reference to AI and IoT. That's what we're going to do the next time. So this is a logical break, and I want to take a few questions.
Sir, maybe we can take a 5-minute break now, sir, since it's
Exactly.
going to be.
Okay.
Yes, sir.
Yeah.
Yes, sir. So we will come back after 5 minutes.
So what time? 11. This is 11:06 now. 11:15 or 11?
Yes, sir. 11:15 will be fine, sir.
11:15. Thank you
Yes,
so
sir.
much. I'll see you at
Thank
11.
you so much, sir. Thank you. Participants are requested not to leave. Kindly mute your audio, please, all of you. Can we continue, sir?
Yes.
Okay.
Okay. So far, right, we talked about the cocktail for a perfect storm. The processor speed, the graphics, the network, the cost of sensors, the types of sensors we have, the data that we are generating, and we talked about artificial intelligence algorithms, right? All this put together is what I call a perfect storm. This perfect storm, right, is not only disrupting healthcare, it is disrupting every industry. Every industry is looking at what can we do with this, right? Starting from your cars, I'm not even talking about autonomous cars. I'm talking about normal car that we are driving today. The cars are becoming a lot more smarter. They are transmitting the vehicle telemetry to the manufacturers. The manufacturers know how many miles your car is running, what the condition of the engine, and they can even call you and say your machine, vehicle is due for a problem, and they can actually know what to change when the car is coming. And to that extent, they are building intelligence into vehicles and so on and so forth. So that this perfect storm is brewing, and one of the challenges that the storm is going to affect or improve is the healthcare. So that's the second part of our conversation, and how this AI and IoT technologies are affecting the healthcare industry. But before we go into the opportunities and what it is going to do, let us understand the healthcare industry per se a little bit, because we are educators, there are many students here, and of course I'm sure there are folks from the medical fraternity here. So the first one is as an individual, right? So all of us are health conscious. The one priority for people is to keeping themselves well, keeping themselves healthy, fit. That's one element of healthcare. The next one is, though we are all happy, healthy, there can be something going on. Especially, it can be cancer, it could be kidney, it could be a heart, the abnormal heart rhythms, or muscles and neurons, and there can be many things that can happen to us. So therefore, while we feel we are good and everything is happy and nice, there can be few abnormalities that can happen. And how do you detect them early? The earlier you detect, the course correction can happen, and the prevention is better than cure. So how do you do early detection? That's a second priority when it comes to healthcare. The next one is, okay, now that I've detected there could be something wrong, we don't know what it is, right? There is a big, say a bump, right? It's somewhere here, and could this be a cancer? This could be a benign cancer or malignant cancer, right? So we need to diagnose that. That's the third element of this. Now that you have diagnosed that this could be a problem, a cancer, now what do you do? That's a decision making. Then what kind of treatment that you give, right? It can be a surgical, it can be a non-invasive treatment, or it can be different kinds of what do you say, giving therapy and things like that. And finally, post-treatment care. I think I did not add the post-treatment care, but post-treatment is another one, right? This is a cycle. So you are happy, healthy, then you have something, we are detecting it, we are diagnosing what it is, then we are taking a decision what to do, then we are giving a treatment, then we have a post-treatment, you are cured, and then the cycle continues. This is the healthcare cycle we call. So now for in every element of this priorities, right, there are opportunities for us. And we also have to look at who are involved in this. I call this as a healthcare value chain. Every healthcare starts with a patient. Somebody either healthy, somebody want to keep themselves healthy, or somebody not happy or healthy, and somebody wants to get cured. So that's a patient. And then we have primary care workers, and especially India being a large country, the hospitals cannot go to every nook and village. So we have primary healthcare workers, villages, rural areas, where the hospitals cannot go or doctors cannot go. Primary care workers make a huge impact. So that's the second category of people that are involved in the healthcare. Support staff, I'm not even talking about nurses. One step below the nurses is the support staff, that those people have to be trained. And then we have the nurses, then we have the physicians. The physicians are different types, people, general medicine, then specialists and surgeons and so on and so forth. And then pharmacists who give you the prescription medicine. And then we have hospitals. So every hospital has an administrator. Running an hospital itself is a huge task. While the doctors and patients and nurses are all focused on curing a disease, the hospital administrators worry about a lot bigger picture in terms of availability of the rooms, scheduling of the rooms, and discharge schedules, and intake schedules, and scheduling of nurses in shift. It's a 24/7 operation, and so on and so forth. And they are also bound by certain legal conditions, right? The records management is a huge opportunity for us to innovate in for the hospital administrators. And then now, most of the developed countries, it's the insurance that takes care of the healthcare. India is slowly getting there. The number of people awareness about health insurance, the group insurance, and the government is supporting with the insurance policies for the poor. So the government supported insurance is there. The public sector or the private sector employees have insurance as one of the benefits for employers. So insurance providers are another one. So everyone has a certain element, and the AI and IoT can touch any of them, and that's what we're going to talk about. So having understood the healthcare life cycle and the value chain, so these are areas the AI and healthcare IoT can actually support. For example, keeping well. On the right side top, you can see keeping well, detecting, diagnosis, taking a decision, giving a treatment. I wouldn't call it as end of life care. The geriatry, as I know, because we all become old at some point in time. We have to become old. We may not be sick, but as we become old, everything slows down, stops, and we have our challenges. So the old age homes, the elderly care, geriatric is another specialty. India is still a young country, but we will become older. Almost Japan is already talking about end of life care or geriatric practice, humanoids, robotics assisted elderly care, and all they are talking about. So I'm sure Europe, US, UK, all will get there. We will probably be the last, but it is an opportunity for us to think about geriatric practice and certain devices and opportunities in that space. And then pharma companies do a lot of research, essentially drug discovery and clinical trials and things like that. And then eventually everybody in this cycle, right, including a patient, has to be trained. A patient has to be trained, the care workers have to be trained, the nurses have to be trained, the doctors have to be trained, and everybody in the cycle has to be trained. And AI and IoT can play a role in each and every one of them. So as an engineer, now we are coming to a little more technical. So as an engineer, as a research scholar or a professor, how do we put all this together? So the way it works is you have an external environment, the patient or anything, and you put a sensor, and you have a hardware, essentially a microcontroller or a specialized chip that actually reads sensor data. It does local decision making. Sometimes, certain local decisions have to be taken care. So we use what is called as actuators, and the actuators will actuate certain things. For example, switching on, let's say, a medicine, switching on a pump that pumps the medicine into a patient immediately when the levels are down. So that's the actuators. And then the embedded hardware also connected to the internet, so that the internet is connected to the doctors or patient or the patient care providers or AI systems that can automatically give a control to the actuators based on the decision taken at the server level, and eventually you have the patient. So the measurement, it's essentially a closed loop system, I would call. So that's the highest level. If you can understand how these work, the next slide will be a lot more easier. So let's, I call this, no, the peeling the onion, right? So it's a big picture, but the devil is in the details. Let's open this one level down and see the next level of onion, right? So we talked about the IoT or AI in healthcare system. It starts with a sensor, right? We have all kinds of sensors. There are sensors that are invasive and non-invasive treatment. So, you know, a temperature monitoring, a pulse oximeter that we have, the blood pressure monitoring. These are all non-invasive. Temperature monitoring, all these are all non-invasive. But there are invasive sensors as well that you have to put it in your under the skin to continuously. Let's say you want to do continuous blood glucose monitoring. How do you do your blood glucose monitoring continuously? Unless otherwise the sensor is pierced under your skin and touches the blood flow, there's no way you can do that, right? So there are invasive sensors as well. So that's one part of it. The second one is the sensors take the data at the point of collection, and then they use the connectivity. There are different types of connectivity scenarios we can think about. And then once the data is connected, it gets into the centralized server where we clean the data and then use it for analytics. Then once it is, you know, analyzed and the data is available for the healthcare providers to think about what needs to be done. So we have a platform for healthcare providers, and then eventually it goes back to the patient in terms of, hey, you know what, you seem to have low oxygen level. So you are supposed to have anywhere between 95 to 100 as your oxygen saturation levels. Your oxygen saturation levels are below 90. There is something wrong. You have to go to your doctor. You have to admit yourself. Now, how that cycle completes and the instruction is given to the patient, or your pulse the blood pressure is shooting up. So the patient is already in the bed, in the hospital bed. So now the blood pressure is shooting up and the nurse is not nearby, but the patient is continuously connected and monitored to the nurse station. So immediately has to be an alarm at the nurse station and the cycle continues. This is the second level of architecture we may think about. But once you understand the various elements of this, let's peel the onion and go to the next level. So this is how probably at a highest level it works. So you have the patient, then you have the caregiver, which is I'm starting from the left hand side. So top left hand side, you have the patient, you have the caregiver, and sometimes the patient also have individual preferences and things like that. For example, there are patients who are afraid of injection, so you have to give them only tablets, right? There may be patients who can't swallow things. They are so old, you can't put things and then pour water. They can't swallow, so which means you have to give them intravenous, right? So the individual preferences are there, and what happens is, see, like every field, right? I think that is what science did to us. It's called as codifying. 1 + 1 = 2, right? MC squared. So these are all codified instructions, right? Medical field also has enough guidelines, codified guidelines. So we can convert every guideline into a rule, a rule book. Then we have experts, you know, they keep feeding the expert data into it. Now that's where the algorithms and artificial intelligence come in there. Now, a combination of patient data, preferences, guidelines, expert input, all put together, the algorithms can decide what kind of treatment advice to be given to a patient. Now, if you look at the patient treatment rate, it can be 2 levels. I have a headache. I have a stomach pain. This can be too complex, right? It can be a low complexity. It can be a simple viral infection. So which means it is a low complexity, right? So, you know what happened? I was awake last night, I was studying, and I didn't have a good sleep. I missed my breakfast, I went for my examination. I wrote my exam and came. I didn't write the exam well, and then I walked in under the hot sun, right? So now you have a headache. Now all the symptoms are essentially telling you that it is not too serious. Maybe a crocin will help you to and have a good lunch and go have a sleep. Probably the headache is gone. So there could be a certain low complexity treatments. At the same time, the headache is splitting. You actually fell down. Your head got hurt, but there was no external thing. But your head got hit on a stone, and you are having a headache, and you are blanking out often. Now that's a high complexity, right? So depending on the scenario, it can be a high complexity or low complexity, and the systems can give possibilities to the caregiver. This can be this. Did you check that? Because a caregiver, you go to the hospital, right? Your nurse perhaps takes care of more than like 10, 20 patients. I don't know the ratio. I'm not a healthcare expert. Every doctor and nurse have a patient care ratio, like how we teachers, we have a ratio for student teacher ratio. They have a ratio for caregiver to the patient and the doctor to patient, the ratio. So what happens is when these caregivers they are switching between every patient. Think about it. Context changes. You are in this bed. You have the medical history. There is always a medical history document right there. You pull out the medical history, look at it, and you give an instruction, and then you move to the next bed. It's totally a new case, a totally a different case, right? Now you have to switch the context and think differently, right? When the doctors and caregivers change context every few minutes between the beds and the situation, there is a chance of they missing out few things, right? So therefore, it is important that we build systems that gives them whether they have done all this. This is why many of the hospitals, right, what you see on the bedside, it is not only the medical history. They also have a checklist to make sure that have you given the morning doses? Have you given the afternoon doses? Have you checked the pulse? Have you checked the BP? There are checklists for every patient, and they have to check and they have to sign that they did it. And those checklists can also be automated. So then you have the treatment decision, and usually the treatment decision, though it is automatic, it needs to be validated with the physician. I don't think we are trusting the technology 100% today. We will never be, right? There will be a human, there will be a doctor or a physician or an expert who will authorize what needs to be done, because a treatment is not just a mechanical decision. A treatment to a patient has many other softer elements of decision, in terms of ethical, financial, emotional, and so on and so forth, personal choices as well. A patient refuses to take the treatment, what do you do? Right? So all that puts together, a patient gets a treatment, and the outcome is fed back to the patient data. The clinical data is nothing but the medical records. So the tests you have done, the readings, the treatments given, how the patient is responding to this daily data, all this fed back to the algorithms back again. And this is where I said reinforcement learning, right? So every time the machine gives you a recommendation, and then you do this recommendation based on the advice, and then that work, now the algorithms are learning, and that becomes a closed cycle. So this is how a complex medical recommendation system works. This is a full architecture. Now this is a technical architecture. The technical architecture is about, I put this as simple 3 layers. At the bottom you have the devices. The devices have to connect to the storage or a centralized server. So you have the gateways or routers or networking connectivity devices. Then it goes to the servers, where first it is cleaned up and stored. Then once you have the stored data, right, you can do notification. The pressure is high. You can even say multiple data that comes in. For example, you did an X-ray, and there is an automated image recognition algorithm that says, you know what, this is not a normal X-ray. This is a COVID X-ray. Now suddenly you have to notify, right? The patient has to be isolated and so on and so forth. So you can have notification, you can have reports. I talked about the checklist, right? As every physician and the caretaker needs to have a checklist, and the checklist will vary from patient to patient, condition to condition, and so on and so forth. How do you generate a dynamic checklist for patient care? So that one. And then the data has to be integrated with other providers. You know, if you are an insurance patient, right? The data, the hospital data, right, has to be given to the insurance provider. So certain integration has to happen. So all this put together is what is the technical architecture, from the equipment to the connectivity to storage to the business application. These are the layers. Now, for those professors, especially those computer science professors, you know, we talk about OSI layers. So this is how the layers work. The basic layer is the sensing layer, the network layer, data processing layer, and application layer. This is how you do the OSI layer architecture. Now, coming back to opportunities, there are many opportunities. I put about top 10 here. The virtual assistant, you know, we can call them as you go into the hospital, or you have certain things to be taken care of. For example, the nurses or staff have to be trained. So what they should do, for example, the augmented reality based devices can actually help a nurse to do certain particular procedure. For example, COVID is a new phenomenon. Overnight, what happened is every doctor and nurse has to train for a new protocol. We call them as SOPs, the standard operating process, right? So what is the standard operating procedure for a COVID patient when a person walks in? Until March, nobody knew what it was, but today everybody knows, right? So when you have a new medical situation comes, a new procedure comes, new instruction comes, the staff has to be trained. There is a great opportunity, especially in the field of AR, VR, is a virtual assistant for staff. The second one is automated image diagnosis using AI/ML. We talked about the deep learning algorithms, right? The computer vision, a combination of CV and deep learning can help you to build some amazing solutions in the automated image diagnosis. We will talk a little bit about it. So which means any X-ray, CT scan, MRI scan, even your ECG graph. ECG graph can be diagnosed for various kinds of anomalies using an image diagnosis. Personal health companions powered by AI. This is a beautiful, simple opportunity. We keep seeing opportunities in this space, or ideas or startups. A mobile application for meditation, a mobile application for deep breathing, a mobile application for yoga, a mobile application for sleep assistant, a mobile assistant for personal fitness, a mobile assistant for healthy eating. These are opportunities in personal health companions. These are simple mobile applications. There is nothing in it. But the point is, what is at the back end is based on the user profile. So you say you are a male, female, Asian, American, just say whatever the profile, and then you are active. Based on your profile, what happens is the recommendation come. And these mobile devices have, for example, Apple Watch has what you call a pulse rate monitor. To some extent, it can even do capture ECG. So it can detect few interesting things early on. So then if you take the data and then connect it to this device, now the device can start giving you some fantastic information. Every mobile phone has GPS. They also have accelerometer. That means when you walk, climb, run, so the GPS and the accelerometer can detect how much you have traveled, how long you have traveled, how much active you are. So every phone has got the steps, how many steps you have climbed, how many steps you have taken in a day. It can give you the healthiness of this, and based on this, you can do personal health companion. That's a beautiful opportunity. oncology, the early detection of cancer. I would rather connect this as well, the AI in pathology, right? So what happens is when you give a blood sample to a lab, the blood sample is treated, the blood sample is kept under a microscope. What happens is they actually see the image. Now that image, can the image be read by AI algorithms and can tell you what's happening? But that's another interesting area. Chatbots, NLP, if you know NLP, you have a chatbot. There are frameworks for this, both open source, commercial, provided by every other, be it Microsoft, Google, Amazon, everybody gives you a chatbot framework. So you can just build a chatbot without writing even a code. So a chatbot based health, for example, this has been a dream for many years. I think the first one was IBM. IBM built a expert system for doctors, right? So you go to the expert system and say, how are you? I'm not feeling well. What's happening? I have a headache. What kind of headache? Where is it paining? How frequently? So it keeps asking you the question. Based on the answers you provide, it tells you what could have gone wrong and what you are supposed to do. But that chatbot, right, provides huge opportunities. Start from admission, you go to a doctor. Imagine you go to a doctor for a common headache. You are wasting the doctor's time for a common headache which could have been used by somebody else. Right? The number of doctors per patient is so low in India as well across the world. So especially now with COVID, you don't even have a chance to go to a hospital. The doctors are not there. They're all busy doing something else. So now I can have chatbots that can give me answers and questions, and based on this, you can say, you know what, maybe you can treat it with the crocin, try it out. If it doesn't work in 2 days, please go to the doctor, and so on and so forth. So robots for explaining lab results. This is a phenomenal opportunity, right? So how many times you went to a lab? I'm sure you have parents, elderly at home, who are supposed to once in a month or once in 3 months supposed to take blood glucose, sugar, urine creatinine, and all kinds of tests. How many of you know the sugar levels? How many of us know H1B/AC, right? How do you know whether the 7 is good or 6.5 is good, 9 is good? So how do you explain the lab results to people like you and me who are not physicians or doctors or nurses? Now, if you can build a system that either use a text to speech, I put on my headphone and I just punch in my patient record or the lab number, it will tell you, it will give you a PDF file, and also it will tell you what's happening without anybody, without any human assistance. Beautiful, right? We talked about AI in pathology, rare disease detection, right? There are certain symptoms for which we know what is happening, but there are symptoms we don't know what it is. Based on the questions asked, based on the data provided, AI systems can flag off saying that looks like this is something new, right? For example, how did we detect COVID? Imagine, how did we detect COVID for the first time? There is a pattern. There is a pattern. And then people looked at the pattern and said, you know what, these patients are coming, we are giving them treatment, but that's not curing, and they are going back home. Next day, 3 people from the same house are coming with the same symptom. Now think about it, right? So this is done by humans. But if you capture all the data enough, there is a possibility that the systems can flag off saying that there is something going wrong here, and then we can do this. This is what is the so-called CDC, Center for Disease Control, in every country is supposed to do. Medication management is a beautiful opportunity for us to think through. What is medication management? So you go to a treatment, post-treatment, a doctor gives you, or post the consultation, the physician gives you medicine. You are supposed to have this medicine for the next 3 months. The biggest problem that physicians tell us is that when we give prescription, patients take the prescription only for 3 days. The doctor writes an antibiotic for 5 days and the patient takes the antibiotic for only 2 days. Why? Second day after taking antibiotics, your fever is gone, the cold is gone. Why should I take the tablet beyond 2 days? You go and ask every doctor, they will tell you that's the worst decision you can do. If you don't take the full antibiotic course, what happens is your body will not respond to that antibiotics next time, because the bacteria will develop a resistance, because the bacteria is not fully killed. In 2 days it is not fully eradicated and it will develop resistant to this. Next time, if you have the same antibiotics, you will not be able to solve the problem. And similarly, there are conditions that you have to have the medicines lifelong. Look at lifestyle diseases, high blood pressure, sugar, diabetes and all that, right? What do? You have to have the medicine lifelong. My own case, my father passed away because he did not take blood pressure medicine for 3 days. Why? It was raining, he couldn't go to a pharmacy and get the medicine. Passed away, gone. So medication management, helping the patient to see whether they are taking the medicine regularly and recording their feedback after the medication. After the medication, my heart palpitation has come down. After I taken the medication, the temperature has come down. But again, the temperature has gone up. I've taken the second course, it has come down. Now, so this is what helps you to find out the efficacy of the medicine that you are doing. This is very helpful for the physicians, because based on the feedback, they can change the medicine as well, or the dosage of the medicine as well. Not only that, the pharmacy companies can get valuable information about the efficacy of the medicine. And health monitoring. A continuous health monitoring is a beautiful opportunity. With all the data, network, the space, the computational power that we have, gone are the days that we have to measure things once a while. We can actually start monitoring, continuous monitoring. There are certain patients, either at ICU or at the hospital or home care, especially old people. As you become older and older, there are chances that you may have to wear a continuous health monitoring. I talked about Apple Watch, right? Think about Apple Watch. Apple Watch provides a continuous pulse rate monitoring on a basis, right? Now we can have devices like that that can continuously monitor when the patient is at home or anywhere outside the hospital as well. So these are the top opportunities when you look at artificial intelligence. The numbers are huge. The business opportunity in each one of them huge. I didn't deliberately touch upon robot-assisted surgeries and all that. The reason being, it's a very invasive procedure, and we have a long way to go there. It needs a lot of expertise. It needs a lot of money, effort to get into the robot-assisted surgery. So I'm not even touching that. If we can do some low-hanging fruits on other elements, fraud reduction, think about it. Where is the fraud reduction in healthcare comes? Who would be interested in healthcare fraud reduction? Insurance. False insurance claims, right? Insurance companies are the biggest losers of medical fraud. So they do systems, as much as you deduct early detection of diagnosis of health condition, they would like to do fraud detection of health claims. So that's another interesting area that we could think about when you are thinking about startup ideas. So So we talked about virtual assistant, right? So your virtual assistant takes the user input through various devices. It can even continuously take the input, or through channels like we can speak. Our WhatsApp has become a bot now, right? WhatsApp for business is a beautiful chat opportunity where the business can take the data, you can ask questions, and then in the back end we have the knowledge resources. Based on the knowledge resources, the response is given. Sometimes it can be a text, it can be an email, it can be a link, it can be anything, right? That's how. So you can ask a question over speech, you can do a chat, you can even say, here is my skin problem, I have an allergy here, and take a picture of the skin condition. Immediately the image is transmitted, and it can tell you, oh no, this is a normal allergy, just don't worry, 2 days later it will be gone. Or it can say, you know what, it looks like a cancer, sunburn, so please apply sunscreen. So it can even be, when I say bot, right, or the virtual assistant, it need not, I mean, it need not be just text, it can be anything. So that's one thing that you could think about. Image diagnosis is a fantastic opportunity, and it is a very interesting opportunity as well. With the Google platform, with Amazon, with the Azure AI platform, everything is available for free to train your algorithms. So all you need is a data set, and there are a bunch of data sets available also. You can locally generate this. It can be X-ray, it can be a CT scan, it can be a MRI scan. As I said, it can even be a ECG graph. You can take any of this and then put through a deep learning algorithms and tell you what kind of output. So this is what, the 3 output layers. It can be healthy, pneumonia, or a COVID. This is just not for images alone. You can even do sound. For example, there is a recently one startup, I think it was in a UK or India, I don't know. They recorded the cough. If you are infected by COVID gives you a dry cough, I believe, right? Whereas a pneumonia or a other cough is a productive cough. They call it as a productive cough or something like that. So the sound of the cough is different. Based on the sound of the cough, they were able to detect whether the person is a COVID or not. Think about it. Now, the mobile phone has a microphone, right? Now, there is a startup that built a heart sound. So all you have to do is switch on the device, keep your phone on your chest, and it can record the heartbeat sound. And then based on the beats, it can tell you whether it is a normal beat or an abnormal beat. Think about it. So it is just not images. It is also the sounds that can be recorded. Based on the sounds, we can actually use a deep learning algorithm to find out certain conditions. This is a huge opportunity. This is a purely software only solution because today every X-ray equipment is a digital X-ray. So they give you digital image out of the X-ray image or a CT scan or anything. So you can build products, you can build startups that does image diagnostics. And an extension of the image diagnostics is what is called as the AI-based pathology. Now, what you do is, here it is a lot more detailed, right? You start working into the cell level, right? And you have high-powered microscopes, and these are all again digital microscope. They give you images. It needs a little bit of integration with the equipment of the manufacturer, but the point is it is still doable that you can take the samples, and you have a pathologist who actually annotate the feature extraction we call. Once you have the annotation and you are training, from henceforth it will be easy to for the device or your algorithm to figure out is this a cancerous tissue or a not cancerous tissue. This is an opportunity. This opportunity you have to work with labs, and you also have to work with the device, the medical devices manufacturers very closely. Continuous health monitoring is a huge opportunity. It can be for normal people, it can be for sports person, it can be for aged, it can be post-operative care or post-surgery or post-treatment care, right? When you are at home, how do you monitor the person constantly? This is a beautiful architecture. What happens is you have a bunch of sensors. The sensors are connected to a local device. For example, it can be as simple as a Raspberry or a microcontroller. Then that device connects to your mobile phone through a Bluetooth or a Wi-Fi, and then your mobile phone is anyway connected to the internet through 5G or 4G, right? Or you can also have your home Wi-Fi. Now suddenly you are creating a beautiful ecosystem. There are a bunch of startups. I know there is a professor by name Professor Maulana. I think he was a principal of a college in Trichy, near Trichy, which college. So he actually quit. He quit that college and started a health monitoring company. I don't remember which company it is, but anybody here, if you know, it's a Trichy, Professor Maulana, I think. So some college name. It starts with Maulana, I think. So he started a health monitoring company based on the same concept. So a lot of startups are working in this space. The problem here is the sensor, the connectivity to the sensor, and then it has to be wired. For example, Apple Watch is a beautiful example because it just you wear it, it is simple, right? But how do you make a EMG sensor which you can still wear, but the patient does not feel discomfort? How do you wear a patch here that starts monitoring your ECG signals, right? How do you wear a watch? How do you wear a bracelet, right? Or how do you wear an ankle, right? So that's how do you wear a belt that can measure a few things, right? So putting that sensors on a patient's body in such a way it does not abstract their regular movement and make them feel comfortable, right? Sometimes you attach a device to a patient, the patient's heartbeat goes up. Have you ever been to a ECG room? You know, you lie down and they put the sensors, immediately your heartbeat goes up, right? So these sensors, when you hook it up to a patient, it should be so natural to them that they should not feel the discomfort of wearing that. That is a most important design element many of the startups have to crack more than technology. So that's the health monitoring. Telemedicine is another interesting one. Telemedicine has been a dream topic for medical professionals across the world. But with COVID, with the technology today, I think telemedicine is coming to reality. So Practo has a platform today. You can remotely fix an appointment. You can remotely chat with the doctor. You can also do a video call with the doctor, and you pay. You don't go to your doctor's office at all. Sitting at home, right in front of your mobile phone or your laptop with a camera, you can actually talk to your doctor, consult, and pay for it. Think about it. Now, Apollo Hospitals has built a platform for telemedicine. They are also offering that thing. Now, it's only a beginning. I'm sure as we go, we will have a lot more things coming into this. Now, think about it. There is a possibility that a hospital or a telemedicine provider can send you that a wristwatch kind of a device. All they say is, sir, you wear it. From now, we'll monitor you. We'll let you know if there is a problem with you. So that's a very interesting space to be. But for you to do this needs a lot of insight into how the devices work, how the hospitals work, how the doctors work, what kind of devices patients need. So it needs a lots of bigger understanding of the ecosystem. It's not a simple job, but it's a huge opportunity. We talked about robotic assisted surgery. I'm not even getting close to this. We are not ready as we are not seriously ready for this. This is again a complex one. We can probably write some research paper on it. It will take some time for us to get here. So we have almost come to the end of my presentation. These are startups These are the opportunities starting from patient facing to doctor facing to telehealth to research to mental health to wearable to personalized genetics to medical imaging to hospital management, women's skin, clinical trials, name it, right? There are thousands of startups focusing on each one of them. The space is still open, it's huge. Not many of them are India based. So if as professors are starting a company or thinking about startups or helping your students, this is a great opportunity. With that, I thank you for the opportunity and we are done with my session.
Any queries from the participant side?
Any feedback, please type in your questions. We can answer.
There is one question. Soumya, can you unmute and speak, or can I read the question?
Yeah, I can see that. The question is, how do we connect smart watches to the cloud, right? So see, the watch is an ecosystem. Apple Watch is an ecosystem. There are a bunch of smart watches. Now, each manufacturer have to open their APIs on the smart watches. I believe Apple Watch allows certain, for example, if you build, yeah, Apple Watch allows apps itself on the watch itself, or you can build app on iPhone. Then whenever the watch connects to the iPhone, we can access certain data. They allow certain data to be pulled up. So which means you have to write an app, a custom app connects to the API or exposed by the OEM and then take the data. So what happens is this is the best way, but these providers are many times very guarded. So what happens is there are a lot of restrictions, and therefore we see the trend that they build their own watch or a device for the specific purpose.
So there is another question posted. Can I read it out, or can you say, sir,
Yeah.
what is feature selection and extraction in machine and deep learning?
See, we talked about feature, right? So let's say you want to detect pneumonia in an X-ray. So you have, let's say, 100 X-rays. Some of the X-rays are with pneumonia, some of the X-rays are without pneumonia or a normal X-rays. Now, how will the machine know which one is pneumonia and which one is not pneumonia, right? So you have to define features that say if you have in this heart, in this, for example, you have the X-ray, right? Your left is the heart and right side is the lungs, right? So we have to go to the right side of the X-ray and look at the lungs, and then similarly, you have to specifically mention where the lungs are to be looked at what, whether it is a white or black patches, and how much of this white and black percentage. So you have to mention all this. That's what is called as feature selection. Now, this is done with the help of experts. For example, you and I can't say, looking at the X-ray, which is pneumonia or which is COVID. You don't know. So we need, that's where the experts will decide how many features we need, how many of the features are very distinctive to define a condition, and then they tell you, and then what you do is you have to manually mark them, tag them. Okay, Jayanti has said very informative and excellent. Thank you, Ms. Jayanti. Venkatesh has said excellent. Thank you, Venkatesh. Okay, Vani is asking a question for an embedded device for health monitoring. How many sensors are minimum required for having it as a wearable device? See, I think the way I would ask this question is not the number of devices, right? What is the purpose for which you are building the wearable device? So I can build the simplest wearable device for measuring the body temperature, right? So then it becomes a temperature monitoring. You can say, I want to put an accelerometer in this and say how active the patient is. So that means in that case, you're going to only put the accelerometer because the focus is to measure the activeness of the patient or the subject, right? You can say, no, I want to do pulse rate monitoring. Then you have to put your pulse rate infrared. Actually, Apple uses an infrared LED and sensor to find the pulse rate. Now you have to put that. Now, if you want to say, I want to build a holistic device, then you have to consult your specialist and say, can I measure temperature? Can I measure gyroscope and measure the activity? And then can I also monitor pulse rate? And then you can also make it little tighter so that, or in a different place like here, and say I want to measure my BP also. Every 10 minutes it inflates and measures your BP as well. So the focus is not the number of sensors, the focus is what you want to measure and what you want to provide value to your customer. That should be the question. Jayanti has mentioned informative session. Thank you, Jayanti. Thomas has mentioned. Thank you, Thomas. Thank you, Vani. Venkatesh is still typing something. I must thank all of you because listening 2 hours of speech is not easy, I can tell you. I don't know why your organizers have made it as a 2-hour session. It's technically impossible to listen to a monotonous speech for 2 hours. Credits to you, you have a lot of patience, especially listening to me. Thank you so much.
In fact, your session was so interesting that I'm sure that participants will not get bored. And we already heard about how your sessions are, and that's why we approached you for our event. And sir, really we are very grateful, and the session was so informative. You had started from the types of data and how huge the data is, and with real life example, you demonstrated where to apply clustering, where to apply classification, where to apply regression. To be frank, this we have not come across in any other session. And in fact, what followed was also how you differentiated between what is deep learning and machine learning. And then the second session even was more interesting because you opened our eyes across the plethora of opportunities in the area of healthcare, and from pathology to robotic surgery. And even you had motivated us with so many startup ideas. I hope the participants will benefit and will think over what was discussed in these sessions and will try to come up with some project in the future, sir. Yes, sir. It is not a simple thank you. Really, it was so interesting, and in fact, we were able to hold the same 50 participants for the entire 2 hours.
Awesome. Thank you. Very kind of you. Pleasure connecting. Wish you all the best. Talk to you soon. Thank you.
Thank you, sir. Thank you.
Bye-bye.